Hello Web API. For our first ASP.NET Web API, we're going to build a simple greeting service. And what greeting is more ubiquitous in programming literature than Hello World? Therefore, we'll start out with this simple read-only greeting API and then add several improvements throughout the remainder of this chapter to illustrate other aspects of ASP.NET Web API's programming model. Creating the service. To create the service, simply create a new ASP.NET Web application from Visual Studio's New Project dialog. From the Web Application Refinement dialog, select Web API. This action will create a new ASP.NET Web API project from the default template. A read-only greeting service starting from the default Web API project template. Add a new controller. You can do this by either adding a new class or leveraging the controller item template provided by Visual Studio. To add the controller using the item template, right-click on the controllers folder and select the Add Controller option from the context menu Figure 3 to 5. Figure 3 to 5. Visual Studio context menu for adding a new controller. This will display another dialog from which you will provide additional configuration details about the controller being created. We are going to create a controller called Greeting Controller and will use the empty API controller item template Figure 3 to 6. Figure 3 to 6. W. EB API controller scaffolding. Completing the item template dialog will produce a new greeting controller class, which derives from the API controller class. T. Have our new API return a simple greeting. We need to add a method capable of responding to an HTTP GET request for the controller. R. Remember that because of our default routing rule, greeting controller will be selected for an HTTP request, API/greeting. T. Herefore, let's add a simple method to handle GET requests as follows. Public class greeting controller API controller. Public string GET greeting. Return hello world. We can now test our web API to see that it is in fact returning our simple greeting. F. Or this. Well, use the HTTP debugging proxy tool called Fiddler. One particularly helpful feature of Fiddler when it comes to testing web APIs is its ability to compose HTTP messages and execute them. We can use this feature to test our greeting API as shown in Figure 3 to 7. Figure 3 to 7. Using Fiddler to compose a new HTTP request. When we execute the request, we can then explore both the request and response using Fiddler's session inspector as shown in Figure 3 to 8. Figure 3 to 8. E. Examining HTTP requests and responses using Fiddler. As expected, this basic HTTP GET request to the greeting service returns the simple string hello world. Content negotiation. Returning to Figure 3 to 8. Take a closer look at the HTTP content type response header. By default, ASP.NET Web API will transform return values from action methods into the JSON format using the popular JSON.NET library first referenced in Figure 3 to 3. However, as described earlier in this chapter, ASP.NET Web API supports server-driven content negotiation, and by default supports content negotiation between JSON and XML. To see this in action, go back to Fiddler's request composer and add the following line to the request header's text box. Accept application/XML, then execute the request again and notice that the response now contains the header content type application/XML and the response body is now formatted as XML. Figure 3 to 9. Figure 3 to 9. T. He content negotiated request and response for our basic greeting. Add a greeting. While it's interesting to be able to get a greeting in different formats, any non-trivial API needs the ability to manipulate the state, or the data, of the system. T. Herefore, we'll extend the greeting service and give clients the ability to add new greetings. T. Key idea is that a client can specify a greeting name and message, add it to the service, and then get it again later via the URL that includes the greeting name. In addition, we need to handle cases where a client misspells or otherwise incorrectly specifies the greeting name in the URL by returning an HTTP 404 status code indicating that the resource could not be found. To allow the client to create new greetings on the server, we need to create a model class to hold the greeting message's name and message properties. We accomplish this by adding the following class to the project's models folder. Public class greeting. Public string name. Get. Set. Public string message. Get. Set. We then create an action method on the greeting controller, which handles the HTTP post request and is capable of accepting a greeting instance as a parameter. The action adds the greeting to a static list of greetings and returns an HTTP 201 status code along with a location header pointing to the URL of the newly created greeting resource. The additional location header makes it possible for clients to simply follow the link value rather than requiring them to construct the URL for the new greeting resource, thereby making them more resilient since server URL structures can change over time. Public static list. Greetings equals new list. Public HTTP response message post greeting greeting. Greetings.add greeting. Var greeting location equals new request URI. Greeting/greeting.name. Var response equals this.request.create response HTTP status code.created. Response.headers.location equals greeting location. Return response. After adding the new greeting to the static collection, we create a URI instance repra, setting the location where the new greeting can be found in subsequent requests. We then create a new HTTP response message using the create response factory method of the HTTP request message instance provided by the API controller base class. The ability to work with HTTP object model instances from within action methods is a key feature of ASP.NET Web API. It provides fine-grained control over the HTTP message elements, such as the location header, in a way that does not rely on static context objects like HTTP context or web operation context. This proves particularly beneficial when it comes to writing unit tests for Web API controllers, as we'll discuss next. Finally, we need to add an overload for the getGreeting method that is capable of fetching and returning a client-supplied, custom greeting. Public string getGreeting string ID. Var greeting equals greetings.first or default equals g.name equals ID. Return greeting.message. This method simply looks up the first greeting where the name property matches the supplied ID parameter and then returns the message property. It is worth noting that there is currently not any sort of input validation on the ID parameter. This will be discussed in the next section. By default, an HTTP post body will be handled by a media type formatter object that is chosen based on the content type request header. Accordingly, the following HTTP request will be handled by the default JSON formatter, which will use JSON.NET to deserialize the JSON string into an instance of the greeting class. Host http://localhost 50650/API/greeting http://1.1 host localhost 50650 content type application/JSON content length 43. Name test greeting, message hello. This resulting instance can then be passed to the post greeting method, where it is added to the collection of greetings. After post greeting has processed the request, the client will see the following HTTP response. http://1.1201 created location http://localhost 506650/API/greeting/test greeting from the location header. The client can then issue a request for the new greeting. Get http://localhost 50650/API/greeting/test greeting http://1.1 host localhost 50650 end. As in the case of our initial read-only greeting service, the client can expect the following response. http://1.1200 OK content type application/JSON charset equals UTF-8 content length 8. Hello. Handling errors. The previous HTTP exchange works wonderfully so long as the server never has any errors and all clients follow the same rules and conventions. However, what happens in the event of a server error or an invalid request? This is another area where the ability to create and work with instances of the HTTP object model proves quite helpful. In example 3-3, we want the action method to return a greeting string given its name. However, if the requested greeting name is not found, we want to return a response with the HTTP 404 status code. F. For this task, ASP.NET Web API provides the HTTP response SE exception. Example 3-3. R. A turning a 404 status code when a greeting cannot be found. Public string get greeting string ID. Var greeting equals greetings.first or default equals g.name equals ID. If greeting equals null. Throw new HTTP response exception HTTP status code not found. Return greeting.message. While it would have been reasonable to simply return a new HTTP response message that included the 404 status code, this would have required always returning an HTTP response message from the getGreeting action method unnecessarily overcomplicated in the non-exception code path. Additionally, the response message would have needed to flow back through the entire Web API pipeline, which would likely be unnecessary in the case of an exception. For these reasons, we will throw an HTTP response exception rather than return an HTTP response message from the action method. In the event that an exception contains a response body that supports content negotiation, you can use the request.createErrorResponse method from the base controller class and pass the resulting HTTP response message to the HTTP response exception constructor. Testing the API. One additional benefit of working directly with HTTP object model instances rather than static context objects is that it enables you to write meaningful unit tests against your web API controllers. Testing will be covered in greater depth in Chapter 17, but as an introductory example, let's write a quick unit test for the greeting controller's post-greeting action method. Fact. Public void test new greeting add / arrange var greeting name equals new greeting. Var greeting message equals hello test. Var fake request equals new HTTP request message HTTP method.post. http://localhost 9000/API/greeting. Var greeting equals new greeting name equals greeting name, message equals greeting message. Var service equals new greeting controller. Service.request equals fake request. // act var response equals service.post greeting. / assert not null response. Assert.equal http status code created response.status code. Assert.equal new URI http://localhost 9000/API/greeting/new greeting response.headers.location. This test follows the standard arrange, act, assert pattern of writing unit tests. We create some control state, including a new HTTP request message instance, to represent the entire HTTP request. We then call the method under test using the context and finally process a few assertions about the response. In this case, the response is an instance of HTTP response message, and as a result, we are able to process assertions on data elements of the response itself. The client is mentioned at the beginning of this chapter. One of the other key benefits to building a ASP.NET Web API around a core HTTP programming model is the fact that the same programming model can be used to build great HTTP applications for both the server and the client. For example, we can use the following code to construct a request that will be handled by our first getGreeting method. Class program. Static void main string args. Var greeting service address equals new URI http://localhost 50650/API/greeting. Var client equals new HTTP client. Var result equals client.getAsync greeting service address.result. Var greeting equals result.content.read as string async.result. Console.writeLine greeting. Just like on the server, the client code here creates and processes instances of HTTP request message and HTTP response message. Additionally, ASP.NET Web API extension components, such as media type formatters and message handlers, work for clients as well as servers. The host developing an ASP.NET Web